In this video, we're covering direct proportion. So, two variables, let's call them x and y, are directly proportional to each other if one variable is a constant multiple of the other. That means it increases by a constant number, but constant multiplication. So, these type of relationships take the form of, let me draw it in here, y equals kx, where, as we said previously, y and x are our variables. They're the things that we input and control. And k is known as the constant of variation. Now, it is very similar to the gradient of a linear function. It is how much x is increasing or how much y is increasing overall. So, there are some features of direct proportion. So, if x increases, y increases. Now, if x decreases, y decreases. They're proportional to each other. Many questions will have a statement such as y is directly proportional to x, or earnings is directly proportional to hours worked. Something along those lines, and they are an indication of how you structure your equation. Whatever comes first, that y is your y value, and then your second term is your x value. It is important to realize that the first thing is your y, the second your x. Y is directly proportional to x. Earnings are directly proportional to hours worked. Things along those lines. Now, when you go to graph these type of equations, they form a straight line that goes through the origin, or 0, 0. So it's important to note that. Now, when you're going to solve these direct proportion problems, there are 4 steps. The first one is you need to identify the variables. And then you form some sort of an equation that takes the shape of y equals kx. Usually you can use different letters than y and x in these cases to mirror what's going on in the example or the question. The second part is, once you've done this, you are usually given some values for your two variables, for x and y. Now you substitute these into your newly formed equation, and then find your k value. Now, it does revolve around doing some rearranging, which we'll go through in one of our examples. Now, once we've done this, we need to go back to that original equation we wrote and created and rewrite it, but this time we change the k to what the value we found it to be. The last one is, usually you substitute some sort of a value for x or y to solve what the initial problem was. So that seems like a lot. There's a lot that we just mentioned. So I'm going to go through an example here to help you out. So Lily's earnings for working a shift at a nursery are directly proportional to the number of hours she worked. She earned $222.70 for working 8.5 hours. Now, it's important again to realize, what did I say before? If I go back up here, y is directly proportional to x. And in this case, earnings was mentioned first, and then directly proportional to the number of hours. So I know that my y is going to be my earnings, and my x is going to be hours worked, or just hours. So I can actually label them as different things. Now remember, the general thing we're looking at, the general form, is y equals kx, but to make it more realistic to the question, I'm going to say that E equals KH, where E is my earnings, H is my hours. I'll just write that a little neater. E equals KX. Alright, now, it also gave us some really useful information up here. We have some sort of an earnings, and we have how many hours it took to get those earnings. This is our step 2. This is our substitution step. So we're going to substitute these into our equation. So we have 222.70 earnings, and then we have k times 8.5 hours. Alright? Now that we've done that, we can do some sort of rearranging. The opposite of multiplication is division, so we'll be dividing by 8.5. And we get 2783.75. There's a point there, equals k. So that's my step 2. So I'll write over here, Here's my step 1 that we did. Here's my step 2. Our step 3 involves substituting it back into the original. So my original is this here, this E equals KH. So E equals 27.8375 H. Alright, that's now my equation. That is the equation that we'll be using going forward. Alright, E equals 27.8375 H. So what we did is we wrote down our general form, changed our Y and our X to appropriate pronumerals or letters, substituted in the values they gave us, the $222.70 and the 8.5 hours, rearranged it to find what our constant of variation or that K value is, and then our last step there was to substitute that back into our original equation, which you can see boxed in red, and then rewrite that as E equals 27.8375 H. Now, part B, how much will she earn for working a 7-hour shift? We've already got our equation that we created. E equals 27.8375 H. So if we know our H value up here is 7 hours, all I need to do is substitute this into where that H is. So 27.8375 multiplied by 7. And that gets us 194.86. So for a 7-hour shift, she earns $194.86. Our next question, how many hours did she work today if she earned this? So this is the opposite of what we just did, but it works the same way. We write down our formula, E equals 27.8375 H. This time, we were given our E value here. So what I'm going to do is I'm substituting that E in. So 144.10 equals 27.8375 H. And then like always, this is multiplication in here, so the opposite is going to be division. So we're going to divide by 27.8375. And what you do to one side, you do to the other side. So over here. And we're left with 5.18 equals H. So to earn $144.10, she would need to work 5.18 hours.